You are currently the only person in this conference.
On electromagnetic radiation. Wow. On purpose. If I take it out. I'd love to see what's in there.
Hello?
Hello?
Sandy?
Yeah?
Hi.
We're not ready. Hi. I'm here.
You are breaking up. I can't hear you clearly.
Okay. It'll be all right. Yes. Everybody can hear this.
Okay. I'm wondering if Dr. Olhoeft or Dr. Bruno...
Nope.
Not yet. Okay.
Katie, does he have the telephone number to call in?
Yeah. And they'll both, they'll call in when they do. And
Bill is on.
Okay. So let's give it one more minute for Dr. Olhoeft, and then we'll get started.
Okay.
In 1 minute.
Is there a Sharon? Does that make sense? No. I gave him a call-in number.
Okay.
I gave him one.
Okay. So if it's is he on yet?
Nope.
Okay.
Yes, here he is. Okay.
Okay, great. So let's go.
Hi, everybody, and welcome to Occupy's continuing conferences on electromagnetic radiation and microwave dangers. Today's date is January 29th, 2015, and today's agenda is all about cars, automobiles, and we have Katie Singer, who is the author of an electronic silent spring with us, who is going to facilitate today's call, except that before we get started on that, I wanted to just say a few things. First, this is an educational conference for all concerned people to listen and learn. So if you have any questions, please use the forum on InterOccupy's Hub, and you can find the link there. And also you can email Katie Singer. She has great ways of answering questions too. So welcome to InterOccupy's continuing conferences on electromagnetic radiation, including microwave radiation dangers. And we have been getting educated on how this hazardous radiation affects people, animals, insects, and plants, and how this harmful effect increases over time. So also I wanted to say that our conferences are every Thursday at 2 p.m. Eastern Standard Time, and also that we have a new link on our hub on InterOccupy, where we have all the conferences located at the present time. So the other thing I wanted to say, the last thing I want to say is the breaking news, is that we have placed a listing in
Okay. Sandy just got dropped off the call. This is Leah, and I sometimes help her out on the call. So she's going to go ahead, I'm sure, and call right back in. Katie, I'm going to turn it over to you till she gets back.
Okay, thank you. And thank you to Sandy. I'm going to begin with the FCC, which formed in 1934 and encouraged people to develop and market new electronics, as long as they did not create harmful interference. The FCC defined harmful interference as anything that interferes with existing radio, TV, and now cellular and internet broadcasts. The FCC has never included biological harm, that is, harm to human health or wildlife, in its definitions. If we're talking about being inside of a car and not wanting EMR exposure to electromagnetic radiation, or wanting less exposure, some cars may be safer than others. How do we determine which cars are safer? And I've also learned, of course, early cars had some electronic components in them. In the 1980s, some cars started using computers. And I'm
Katie, it started earlier than that.
Okay,
Just spark plugs are huge transmitters.
Okay, great. So I'm going to admit, that was Dr. Gary Olhoeft. I'm going to begin by admitting that I know very little about how cars work. Witness what Dr. Olhoeft just came in with. And I think, at least in part, I don't know very much because I did not come from Gary Olhoeft's family. Sometime in the mid-1920s, when Gary's father wanted a car, Gary's grandfather said, okay, you can have a car, but before you drive it, you've got to take it apart and put it back together. I'm hoping we can do a little of that today. So my guests are Dr. Gary Olhoeft, who is an electrical engineer and a geophysicist. He's professor emeritus from the Colorado School of Mines. And we're also joined by Dr. Bill Bruno, a biophysicist who worked at the Los Alamos National Lab for 20 years and now does research at the New Mexico Consortium. Gary, I've got a bunch of questions for you. We're going to start with you, and I'm going to say you may only be able to join us for about a half hour today. So we'll work around that. But go ahead, Dr. Olhoeft.
I'd also like to say in the agenda there was attributed to me a quote. I am particularly concerned about the radiation exposure of children and pregnant women riding in these new vehicle types. I did not say that. That was a quote from one of the prior questions by Glenn Bengi.
Okay. And then you responded.
And we don't have any
question.
information to tell whether or not that's true or not.
Okay.
But I am particularly concerned about medical implants. We do know that those are sometimes interfered with.
And I just really want to appreciate your bringing that up. And let me clarify that my understanding is that you can probably say it better. You were trained in the scientific method. And so what we're looking for here, we've got people with experience saying, when I get into a car, some people with medical implants get into a car and their implant shuts off in certain seats or in certain situations on the road. And that's kind of scientific because it can be repeated, and we
can measure it.
We can measure it.
Determine it's happened.
We've got
and
one.
Repeat it, yes.
Okay, so we've got one electronic device interfering with another electronic device. If someone says, every time I get into a car, I get nauseous or I get ear ringing or something like that, okay, that's an interesting observation. Do we have studies that show evidence that that is a problem X percentage of the time? To my knowledge, we don't have such studies.
No, they're just beginning to think about studies like that. In fact, I've just found a new site on the web where people are talking about having trouble with diesel cars because the new diesel cars have computers in them, and they're ham radio operators, and when they key the transmitter on their ham radio in their car or truck, it overloads the computer and turns off the car.
Okay, so Dr. Olhoeft,
that's sort of the reverse interference.
Okay, let's go let's go to the beginning, or what I'm thinking is a beginning for me. Can you tell us, what does a current car use computers for? What are the current uses of computers in current cars?
All kinds of things. And in fact, there's not one but many computers in most cars these days. New cars have computers that control the emission system so they can pass emission testing, fuel, gas mixtures.
And then you're talking of emissions of what?
Exhaust. Like in California and Colorado, we have emissions testing that's done to make sure, in fact, the newer cars in California are cleaning the air. their exhaust is so clean. But that's controlled by a computer.
Okay. What
Computer
else?
controls the electronic locks. They have cellular systems, Bluetooth, Wi-Fi. They have all kinds of electronics in them.
Can we slow this down? So how do computers control the locking in a car? What locks get? How does the computer do that? What locks
Some
are you
cars
talking
have
about?
these new keys that you just have to walk up to the car and it unlocks itself because it recognizes the owner with a key.
You mean the key is just in the
computer and a
person's...
Wi-Fi system.
Wait. So the key is in the person's pocket? Or where
Pocket, purse, somewhere nearby. Gets within so many feet of the car and it'll unlock the car. If you walk away, it'll relock the car automatically.
And so a computer is doing that?
There's a radio transmitter involved on both ends. And the computers recognize a small computer, but it's nonetheless a computer doing that.
All right. I'm going to go back again to my
Airbag
first grade.
sensors are controlled by computers, so they know when there's enough G-forces involved, they need to deploy the airbags.
Can we go back to spark plugs? So so spark plugs?
The original,
most people, what do they do?
gasoline engines.
What does a spark plug do? I'm in first
Okay.
grade. Tell me in first grade what a spark plug does.
Well, first of all, a diesel engine does not require a spark plug. It just requires compression. A gasoline engine requires a spark plug to cause the ignition to occur. A spark by its very nature is a very wideband source of radio transmission, and it's regulated by the FCC for arc welders as well as spark plugs in your car and other things.
What does the FCC regulate there?
How strong it can be.
And why would it do that?
They put filters in cars with spark plugs to eliminate the RFI from the filter interfering with your radio. Otherwise, all your AM radio would pick up would be the spark plug.
Okay, wait. I want to slow that one down. So you're saying...
so they filter it out.
Okay, so that the noise from the spark plugs would be so strong that I would not be able to hear my radio if there wasn't a filter filtering out the noise from the spark plugs. Is that correct?
In an AM radio, yes.
Okay.
FM
Not
radio
in an
works different, and digital radios are different yet again.
Okay. And so today there are spark plugs operating in what way? Do they interfere with radio?
We talk about 8 cylinders. It's got 8 spark plugs. Each cylinder has a spark plug to ignite the gas, the fuel-air mixture to make the engine work.
Okay. And then how come I can hear my radio no problem?
Because they have filters to remove the signature of the spark plug so it doesn't interfere with your AM radio. This is amplitude modulation.
What about when we get to FM, frequency modulated radio?
Then it doesn't pick it up.
Okay.
If you were in a car listening to your AM radio and you see a nearby lightning strike, you'll also hear it on your radio.
You'll hear the lightning strike on the radio.
Your spark plug is like a little lightning bolt in there. But it's very small and can be filtered out because it's so weak. When we talk about interference, we talk about amplitude, frequency, and duration. The amplitude is small, the frequency is broadband, so it interferes with almost everything. The duration is also small for a spark plug or a lightning bolt.
Let me bring in Dr. Bruno here for a moment and see if he has something to add about the kinds of computers that current cars use.
Can you hear me, Katie?
Can you talk a little bit louder?
Do you hear me now?
Yes.
Yeah, I just wanted to mention that, for instance, in my wife's car, the radio has a little TV screen built in with it, and you can just pull the fuse out, and that, of course, you can't listen to the radio then, but the car drives fine, and that in that particular car, that's a pretty important source of radio interference. If you hold an AM radio up to that screen on the car, it'll buzz a lot, like Gary was describing. Also can happen with spark plugs if you hold the radio close to a car with spark plugs. If it's a regular handheld AM radio, the old-fashioned kind, analog tuning, the radio will buzz and you'll be able to hear the spark plugs that way.
You're talking about a cheapo $12 portable AM/FM radio.
Yes.
And and just for listeners' sake, in my book, Electronic Silent Spring, I do describe how to use a portable AM radio as a kind of Gauss meter, and that's what Dr. Bruno is talking about. Okay.
High-frequency Gauss meter, you could say.
Okay. Dr. Olhoeft, can you describe the difference between an electric car and a hybrid car?
Usually an electric car has only an electric motor, and a hybrid car has both an electric and a gasoline motor. The gasoline motor takes over when the electric batteries are discharged and recharges them, and the charging circuit can also emit interfering electromagnetic waves.
And what about a diesel car?
A diesel car usually has no spark plugs, but it may have glow plugs if it's in a cold weather environment to warm it up enough to be able to make the diesel work. But diesels are much better. Newer diesel cars, however, have the same computers to control the air-fuel mixture to optimize it so they meet emission standards.
When you say
about the output of the exhaust pipe when I say emission standards, not radio emissions now.
Okay. When you say diesel cars are better, in what context are you referring?
They don't have spark plugs, so they're not generating their RFI of a spark plug.
RFI meaning radio frequency interference.
Right.
Okay. Dr. Bruno, what do you have to say about diesel cars?
I drive a diesel car myself, but as Gary was saying, the newer diesel cars, it's not just that they have a computer in them, but they also, because that computer is controlling solenoids that control the valves in the engine, that's a significant source of RFI, radio frequency interference.
What's a solenoid?
It's a coil that when you send electricity through it, it's a little electromagnet that will pull the valve open or push it closed. And
it's like a small motor.
Right, and so it takes quite a bit of current. You want to move that thing quickly, so you put a big pulse of current through there, and so that will generate pretty bad electromagnetic emissions. So with diesel cars, you're better off with the 1980 era diesel cars that aren't computer controlled.
Okay.
One of the problems with cars is that the engine can be in the front, the middle, or the back. And unless you know where the engine is, you can't tell what it's going to do. You can model such things, but it's better to measure the electromagnetic interference, the radio frequency interference for each car. Because they come with so many options, it's hard to predict what it's going to be like.
All right, so let's start looking at that. What kind of electromagnetic radiation, EMR, what kind of EMR emissions would a person in a car be concerned about? Should a person be concerned about? Gary, you want to start us off?
Well, the engine, the computer's controlling the engine, the computer's controlling airbags, the computer's controlling keyless entry systems to figure out whether or not it's your car or not. There may be a computer-controlled security system in the car. There may be charging systems for batteries, if it's electric or hybrid. Or even if it's not, there'll be an alternator for charging the regular 12-volt battery that starts the car.
And what's
There's all
problem?
kinds of systems.
Well, so what's the problem from, what is the EMR that a person might be concerned about?
The problem is we don't know what it is in any given car without measuring it, and there's no regulation of most of this stuff. Theoretically, the FDA should have the power to regulate this stuff because its frequency is mostly below 9 kilohertz. But some of it's above that, and the FCC steps in. The FCC's regulatory authority starts at 9 kilohertz and goes up to 300 gigahertz.
Okay, let me clarify.
Most of the radio stuff, most of the computer stuff, the regular low-frequency electromagnetic motors, like you'd find in a car, motors that would be in your powered windows and other powered things, as well as the motor that drives the car on the wheels, That's a much lower frequency, and that's not regulated by the FCC anymore, but the FDA has the authority to regulate it. And they do regulate it for wheelchairs.
Oh, okay.
Sorry?
All right. Yeah, I want to slow this down and just repeat what you've just said. So below 9 kilohertz, that is regulated by FDA. Those emissions are regulated by FDA, and those would be called lower frequency fields or extremely low frequency fields. Above 9 kilohertz, those emissions are regulated by FCC. And what we're talking about in a car, usually, what I'm understanding is that most of these computers are emitting lower frequency fields. Is that correct? And sometimes they emit...
No, the computers themselves are emitting higher frequency fields, but what they're controlling is often emitting lower frequency fields, like the chargers and the windows and the airbags and the engine itself.
Okay, and let me clarify that lower frequency fields and higher frequency fields can cause biological harm according to some studies. So just because we're saying the term lower frequency fields does not mean that that's harmless.
Right.
Or that it can, and even from one electronic device to another, you can get interference with lower frequency field emissions. Okay, so Dr. Bruno, can you respond to that question? What kind of EMR emissions would a person be concerned about in a car?
Well, I think Gary covered most of it. The one other thing that comes to mind is, I'm not too sure about this, but the anti-lock brake systems, there's probably some kind of, that is computer controlled, and there was a study done where they measured low frequency fields in different cars, and they found that they got the highest readings under braking. Of course, they're measuring down near the driver's feet, and it's easy to imagine that there are currents that that are used to control the brake modulation when you're braking hard.
Modulation.
There are also hydraulic systems that do that, so it may not be electronic entirely.
It is computer controlled.
But it just occurred to me, the electric seats with their powered seats and heated seats are probably the closest thing to your body that would have an electrical emission.
That's true, although hopefully the heated seat is DC, but of course it's not very clean DC because of all the other computers that we were just talking about.
Right.
You're talking about the difference between direct current and alternating current, and
yes.
Listeners might want to go to the book An Electronic Silent Spring to learn the difference between DC and AC.
Doesn't your website have a glossary too?
Yes, I do believe that does. electronicsilentspring.com. Thanks, Dr. Olhoeft.
The other thing
Dr.
that comes
Bruno?
to mind, Gary mentioned the charging systems. One thing that's been found is that when the battery, so even in a regular conventional car, not a hybrid or an electric car, but a gas or diesel-powered car, if the battery is in the back of the car and the engine is in the front, and the charging system's in the front, then you often get low-frequency fields throughout the passenger compartment.
Because there's communication between the battery and the engine?
They're sending pulses to try to charge the battery that come from the engine. And usually there's only one cable that runs, and so the return current goes through the entire body of the car. So you get a magnetic field everywhere between where that wire is and where the return current flows, which is everywhere in the car. They've, in some cases, Volvo, actually this was kind of exposed in year 2002, I think. Volvo, some magazine in Sweden, measured these fields, and they were quite high, about 120 milligauss, if I remember. And Volvo decided to correct it for a lot of customers. They put in a second wire so the return current would cancel by having two wires there instead of just one wire. The fields cancel, and so the fields are only high when you're close to the wires in that case. But it's still, as far as I know, to this day, there are still cars that have that issue where the battery is on one end, and most hybrids and electric cars have that issue too. The charging, if you do regenerative braking, then you have charging coming from every wheel, and it's all going back to the battery pack. So people may be sitting right over the wires that are transmitting this. And now, of course, it's, as I'm sort of implying, that it's possible to make an electric car. If you design it carefully, you can make the electromagnetic emissions low, but there hasn't been enough serious concern about it that it's worth spending the money right now. Except,
this doesn't even count the electronic devices that people may be bringing into the car themselves. Like you've got 5 passengers, 4 of them working on the cell phone at the same time.
This is something I'm qualified to speak about. That one thing you can do if you want to reduce your exposure to electromagnetic radiation is don't use a mobile device inside of a car. And the reason is because as you're traveling, at every mile, while the phone disconnects from one cell tower or base station and reconnects to a new one, the phone goes to maximum power. And all of that emission, the electromagnetic radiation emitted by the phone in that reconnection, gets trapped inside the car, which is essentially a metal box. And there you are in the car getting the radiation. And oh my goodness, if there's more than one person doing that in the car, that's going to be very strong. I would also expect that even if the phone is just simply turned off, it's still going to be searching to see if you've gotten a message, and you're still going to be getting that radiation trapped inside the metal box while you're traveling along. Okay, can we look at the question, how do you measure? So both of you are saying that different cars have different EMR emissions. How do you measure, and what do you measure for? Dr. Olhoeft, do you want to
measure as a function of frequency. At low frequencies, you measure the magnetic field, and at higher frequencies, you measure the electrical field. And there are devices called spectrum analyzers and magnetometers that make these measurements.
Is there a way to do it inexpensively?
No, not correctly.
So can people, I would say Magnetic Sciences I don't know if they're .org or .com has some meters that you can rent for a couple weeks at a time. Can you get it? How can you get a rough estimate of the magnetic fields or the radio frequency field emissions? Is that a relevant question?
Well, as Gary was saying...
Yes and no. It's a hard question to answer because there's so many variables involved. I mean, if you've got a vehicle that drives sometimes on two-wheel drive and sometimes in four-wheel drive, and you measure it in two-wheel drive and it never triggers the four-wheel drive because you were testing in the summertime, you're going to get a different answer than you would in the wintertime when all four wheels were engaged.
Okay.
I agree with that. Also, Gary mentioned that a lot of these things that cause these emissions, like spark plugs and charging regulators and computers, they tend to emit square waves. And so,
and what is a square wave?
Well, if you make a graph of the magnetic field as a function of time on a very short time scale, you'll see it looks like a bunch of rectangles instead of, a sine wave is a nice smooth curve. A square wave, the voltage or the field jumps and then jumps back down again. So
and what's the problem with the square wave?
Well, that's kind of a long discussion, but what I wanted to say right now is that it helps a little bit when you're trying to measure these things, because whereas a sine wave, you have to have a receiver that receives at the frequency of the sine wave to pick it up. A square wave, it's more easy to pick it up by accident. If you just have a fairly broadband detector of some kind, it may pick up one of the harmonics from that square wave. And so as a sort of cheap man's way of trying to measure these things. You can, we mentioned the AM radio. That's pretty good for any square wave that's below about 1.5 megahertz. You have a decent chance, especially if you tune around to different parts of the dial, of picking that up. And then usually you'll hear some kind of buzzing or some kind of repetitive sound that will go away as soon as you move the radio away from the car. There's also fairly cheap magnetic field detectors, like $100, $200. There's even some less than that that will measure low frequencies. But as I think as Gary was implying, unfortunately, some of them only measure right around 60 hertz or 50 hertz for the power line frequencies, and that's really not relevant for a car. You want one like the tri-field meter that Alpha Labs makes, goes up at least to from about 50 hertz to about 100 kilohertz, 100,000 hertz. So that's a pretty broad range of frequencies. I think
there's also the problem. You're moving. If you're in a car and you've got the engine on and you're trying to measure its magnetic field and you're moving, the moving car is in the Earth's magnetic field, which you will also pick up. Depending on how fast you're moving and turning and so on, you'll be picking up a background that's there all the time that's natural.
Right, especially...
And it's not necessarily bad for you.
Right. Especially if your magnetic field detector goes too low in frequencies, like down to 20 hertz, then just holding it with your hand, your hand is going to be vibrating at 20 hertz, and so you'll pick up the Earth's fields, even though that's not what you want to measure. So it's good to have one that doesn't go too low in frequency.
Okay, now, what are the problems? So you're saying we can get magnetic fields and radio frequency field emissions from some of the computers used in cars, or even some of the, would it be correct to say some of the wiring
yes.
installed in cars? So what are the hazards? And I'm actually wondering, Dr. Olhoeft, if we could start with the situation of medical implants, which you've spoken about before, because there, again, we've got a sort of scientific evidence of the situation. What can happen in a car if a person has some kind of medical implant? What's possible? What have we observed?
Well, we have only observed this a few times, but I have talked to people who have had this happen, and I've had it happen to myself. I know a woman who, when she's driving her Toyota Prius, and then she puts on the brakes and it goes into the charging mode, she has a deep brain stimulator. The deep brain stimulator turns off. I have a deep brain stimulator and a Prius, so I've done the measurement myself, and it turns out when it goes into charging mode, the Prius generates almost 3 times as much magnetic field as the controller for the deep brain stimulator.
And let me clarify that what you're talking about is when the Prius brakes, that signals the car's computers to recharge the battery, and that process creates intensified magnetic fields. Is that correct?
It creates a magnetic field 3 times stronger than the controller for the deep brain stimulator, so the deep brain stimulator turns off.
Okay. Now, does that matter what seat you're sitting in the Prius?
I don't know. It does in my Prius, but I don't know for all Priuses in all years.
And we do
the system has changed over time.
Okay, and we've got a report from a woman who was driving her Prius after her deep brain stimulator was installed, and that, of course, would be extremely hazardous for a driver to have his or her deep brain stimulator shut off while driving.
Right.
But we don't have
You have a few seconds to turn it back on. And it depends on how bad this is a treatment for Parkinson's disease. You start to shake.
The deep brain stimulator.
And depending upon how much you shake and how much the deep brain stimulator can ameliorate that effect, you may have trouble turning it back on.
Which would be a major traffic hazard.
You'd be sitting there in traffic, not able to move.
Right. Okay. are there other experiences? Like what if you're driving under a cell tower? Can that affect the function of the implant?
It's more your cell phone that would do that because it's closer to you.
So
but I don't know.
Okay.
It depends on what cell tower it is. Some cell towers only have a few antennas on them, and some of them have a dozen or more antennas on them. And so there's a difference in the amplitude of the signal and the frequencies that are covered depending on how many antennas are on the tower.
And different deep brain stimulators could be affected differently as well.
No, it's not just the deep brain stimulator, but you may actually cause inductive heating in the wiring of the stimulator and damage the brain.
Okay. Dr. Bruno?
I wanted to add that I've measured a lot of emissions from cell towers. Not a lot, but from several different cell towers. And the number of antennas can make a difference, but the other thing that makes a big difference is how high up it is. And so often the most dangerous ones are actually the ones that are disguised into the building, so they're almost not visible. They may look like pipes on a roof or flagpoles or
a chimney.
Some look like trees.
So really it's, I think the biggest emissions come when you're sort of at level with the antenna, because most of these microwave antennas are fairly directional. They don't transmit up and down as much as they transmit to the side. So when you're right in the beam is when you get the highest exposure. So whenever there's one that, it's a big problem if you're in a building that's right across from another building that has them on the roof and your building is almost as tall. It can be quite high emission.
You can also get quite high emissions simply by passing by a broadcast tower for broadcast TV or radio. Those are frequently much more powerful than a cell tower.
And could those can affect the medical implant, you're saying?
Yes.
Okay. And then part of this whole discussion today really got started by a question from somebody who was asking about pregnant women and children riding in cars. And one of the things that occurred to me is I have heard this, I don't know if it's true, that the manual for some hybrid cars warns owners not to allow children to sit in certain seats.
I can believe that, but I have not seen that.
Okay. But in other words, you would want to read the manual of your car before you proceed. Are there other... Dr. Bruno?
You mentioned pregnant women. I do remember there was a study of miscarriages caused by low-frequency magnetic field exposure. And I think what they found was that it correlated most with the strongest exposure during the day. Now, it wasn't, they didn't do a whole lot of measurements, but that's the one data point that we have suggests that, that you could have low magnetic field exposure all day long, then you get into your car and suddenly get high exposure just for a few minutes, and that might be enough to increase your risk of miscarriage.
And you're talking about magnetic fields that would be emitted in a car, and if you're in the car, those magnetic fields are going to be trapped inside the metal box, and it could be very strong.
Well, the metal box isn't that big of an issue,
in that case,
at low frequencies. But and even at high frequencies, I don't think it's a big issue unless you have tinted glass that reflects it back in. But it could also, it could be that for some people their vacuum cleaner, their hair dryer is a much bigger risk than their car, but these are all, or their TV set. There's many risks out there.
Or their electric toothbrush or their electric shaver. Those are two things that I can't use because it's too close to my head where my deep brain stimulator is.
Okay. So if you were going to... So let's go over again this question that came from some concerned man about the exposure for pregnant women and children. What would you say would be precautionary practices for a family with a pregnant woman or children that they want.
Buy an older car.
What age is older? Starting what year?
Pre-1980 something. I'm not sure exactly what the date would be.
There's
a lot of problems. People don't just ride in cars. They ride in buses. They ride in trains. There are electric trains. Here in Denver, we have light rail. I'm trying to figure out what the hazard is from those things.
For people with medical implants, or for
people with medical implants in particular, because I'd like to know whether I'm safe riding on them.
Okay. Dr. Bruno, what's your idea about how to protect pregnant women and children in cars?
Well, it's a tough question, but it reminds me of something I read I was looking last night at some of these websites. There's actually a website devoted to hybrid cars. I think it's called hybridcars.com or something, where this question of a magnetic field was raised. And they have quite a discussion of it, but at the end they basically say, you could always just wear a tinfoil hat or join the Amish, That's their solution.
Tinfoil hat wouldn't do it.
I know, it wouldn't. But the Amish actually would help. And we know, I think there's studies that the Amish don't have some of these, they have a lot of health problems, but they don't have as much Alzheimer's disease and some of these other.
That's changing.
Yeah, that's unfortunate. So it's hard, but I think for somebody who spends a lot of time in their car and has the ability to buy whatever car they want, an old diesel truck or an old diesel car. Of course, then you've got the diesel, old diesel cars, and you're going to get a lot of chemical smells coming out of that. If you're chemically sensitive, then that's another problem. It's not easy. And now I guess it's also possible to try to shield the car. Just sitting back, for some people, like I've heard of people who just put blocks on their gas pedal and their brake pedal so that they can sit further back from the, a lot of the emissions are often coming from the dashboard area behind the instrument panel, and in the footwell there's like wiring down by the brake pedal and the gas pedal, and also on the sides sometimes, mostly on the right side, especially the transmission often is right there under your right knee kind of, and it may have strong emissions.
Right, a lot of it's coming up the steering column because we've got all these buttons on the steering wheel that control things now.
So that would be a thing, to find a car that doesn't have a lot of buttons on the wheel. That would be a starting place.
Well, it's better to just take an AM radio, I think, and turn the car on, and rev the engine, or take it for a drive, and see if, especially where your head is, where your inner organs are, does the radio buzz at those places? If it does, I'd consider it a hazard, and that can be blocked by aluminum foil. And then you also want to, measure low frequency fields.
So what would you wrap in aluminum foil? Say that you found a buzz. What would you wrap in aluminum foil?
Well, you have to have, it depends on the exact situation, but like in my wife's car, putting it on the side of the transmission housing blocks some of the AM radio noise that comes from the transmission.
That's like in the knee or lower leg area?
Right.
Okay. Can you also talk about shielding the windows? When we talked earlier, you were explaining the difference between shielding the windows for ultraviolet rays and then for EMR exposure, say from cell towers or broadcasting antennas for TV or radio broadcast. Can you talk about that a little?
Right. So I think if you're somebody who finds that just being near a cell tower is enough to cause some kind of reaction, then you can actually shield the car windows. And I measured a car that had that done, and it was impressive, the reduction. It was like a 100-fold reduction. But it depends what kind of tint. So most tints are designed to radio frequencies through because they know that you want to use your cell phone in the car. If you do this, then you have to absolutely not use a cell phone in your car and not allow anyone to use it.
And the reason would be?
Well, because now, as you said, it's like you've created a little microwave oven for yourself. You don't want to have a microwave transmitter and no way for the signals to get out because they're going to bounce and just get stronger and stronger.
So once you do put shielding on the windows, then you absolutely do not want to use or you have any kind of wireless device inside the car, including a cell phone turned off, because it's still going to be searching for a signal.
Right. You could take the battery out.
None of it's really turned off. Most people don't know how to really turn them off, though.
You want to tell us?
Most put them in standby mode.
How do you really turn off a cell phone?
If you want to be really sure it's off, do what Bruno just said. Pull the battery out. The trouble is you can't do that in all cell phones.
So the problem is, Gary, some of them, you can put it in airplane mode or turn it off and have it really be off. But we now know that the NSA and the FBI have the ability to turn your phone on and listen to you. So when, if that's happening, of course, if you're not a drug dealer, maybe you don't have to worry. But anyway, or a terrorist. So taking the battery out, and as you said, a lot of phones, the battery doesn't come out anymore. So. Also, a Wi-Fi laptop would also be dangerous in that respect if your laptop was still transmitting.
Let me move in here with a question that Sandy Fields actually raised about police officers and firemen and firewomen, that their cars now are outfitted with lots of computerized stuff, so that they can respond. And I mean, they've got to be looking at a computer, to get directions for what their next assignment is, all that stuff. How do those computers affect their health as, I'm going to call them workers right now? How do those computers affect things, affect health? Or do they create more emissions?
Probably. And Katie, I don't know if you realize, but most people drive with a little screen for navigation these days. If not their cell phone, it's built into the car, or they add one on to their dashboard somewhere that gives them a map so they can get where they're going.
Would that be a concern? What kind of emissions would that be giving off?
Well, just the same emissions as a computer and a screen. And it depends how well it's designed. I would.
Some of the newer cars have Wi-Fi systems built into them, radar systems built in to detect cars approaching on the sides, automatically brake when they're in reverse, and all those things. Those are all potential hazards we know nothing about right now. So
again, I'm going to go back to quoting you, Gary, that in order to be precautionary, buy an older car. Okay.
Well, I found this site Bruno was just talking about, hybridcars.com.
Yes.
That's electromagnetic fields.hybrids, talks about the Volvo problem. And his solution is move to Amish country.
And get a horse, I guess, right?
Yeah, get a horse.
Okay, well, and I have a lot to say on that because I live in Amish country frequently, and I can tell you it's that's an illusion that Amish people are shielded from electronics problems. And one thing is a lot of them have generators in the barns and all that stuff, and those are causing all kinds of other problems. Can you talk about toll booths? So, Dr. Olhoeft, if you drive, past, if you're in a car and you have to go through a toll booth, those easy passes.
Yeah, remember duration's important. If you go through at the normal speed of a car and you don't stop and sit there for a long time, if you actually just drive through, it's not a problem.
Okay. You're saying for a person with an implant.
Right.
Dr. Bruno, do you have an opinion on that?
I do think it's unfortunate that there's this exposure that we have very little control over or say about. It'd be nice if they had a special lane where no exposure. But yeah, I think Gary, I don't know of people who have had problems with those specifically, and we don't know enough to say, whether a very brief exposure could change the risk of miscarriage or other problems, other cancer issues, and so on.
What about with public transportation? So buses, which, subways, Amtrak trains. I mean, I know that most of these now have Wi-Fi. And, of course, they're going to have the same engine and wiring situations that that automobiles have. What do you?
Well, but the engine's in the back, so stay in the front of the bus.
Okay.
I don't know where the Wi-Fi is because I haven't seen a bus with a Wi-Fi. And I'm testing the electric trains in Denver right now to find out. I have a student running around with a meter measuring things.
What about airplanes?
Small airplanes are all right. 10 passenger and above typically have 400 hertz power systems that are very strong and bad for people with implants.
And what about for pregnant women and children? Would that also affect pregnant women and children?
We don't know.
So how would we?
And again, it depends on where you sit in the airplane.
What would be a better seat?
I don't know. That's a good question.
Of course, it's tough these days when you're crowded with other people who are all using their smartphones.
Wi-Fi enabled devices and cell phones on the airplane and filling it full. 100 people with Wi-Fi devices and cell phones is not good either.
So you would want to be further from the engine, further from any router, and far from a person with a smartphone.
Also, I think the planes usually have a strobe light under the wings that draws a lot of current. So I've measured big fields right near where the wings are on airplanes.
Depends on where the engines are, because the engines generate the power.
All right, so we've got maybe 5 minutes left here. Can you say what you think the most important precautionary behaviors would be for someone who needs to be transported somewhere to get around, in a reasonable way? What are things that people can do in a precautionary way? Say that they are going to have
as little time in the vehicle as possible.
Okay.
I guess also if you can sit in the back seat, as long as there's no engine or battery in the back, then I think your luck is probably better in the back.
Battery in the Prius is underneath the back seat.
Yeah, not a Prius. And actually some cars also have cell phone antennas near the back and so on. But an older car in the back.
I've heard that there are, I don't know what. Go ahead, Dr. Bruno.
So one of the studies I found that they measured a 1966 Volkswagen Beetle, and they found to me the fields are still pretty high, but compared to most cars, they were pretty low. And I guess it's because the engine's in the back, you're sitting in the front. So, but I think in that car the battery is in the front, so it's probably not an ideal situation.
I've heard for people who really want to have a cell phone use while they're driving, that there's some antenna you can put on the roof of your car that makes the situation safer. Do you know about this?
No, I don't think there's anything like that would work.
Because?
What do you mean by work? Certainly less emissions than holding it right next to you.
Can you say again? I didn't hear you, Dr. Bruno.
Well, I'm not sure I can recommend it, but I do think that if you have an antenna on your roof, it's better than having it, in the car next to you or up against your head, certainly. And a lot of newer cars have a system like that built in, like a Bluetooth.
Inside the car.
So that's, certainly preferable to making a call. I mean, it's probably, in most states it's illegal to make a call with your phone in your hand anyway. But
if you're driving,
right, if you're the driver,
you could still have 4 other people in the car with you who are not driving and talking on their phones.
Or
you asked about top priorities.
Yes.
I had a thought, but I've forgotten it. I guess it wasn't that great of an idea. I guess I said sitting in the back seat.
If it's not a Prius.
Oh, the other thing I wanted to mention is if there's somebody who's like really sensitive, disconnecting the alternator. So get a old diesel car, disconnect every computer, and then disconnect the alternator. Get a deep cycle battery and put a solar panel on the roof. And then periodically you have to check the charge on a regular basis and charge the battery as needed. That's sort of the ultimate solution.
Is there a website where people can find out how to do that?
There is somebody who calls himself ES Engineer, ES for electrosensitive, and he describes modifying a Mercedes diesel in that way.
Are there other websites that either of you can recommend for people who are concerned about EMR exposure in cars or other vehicles?
There is one called the happyhabitat.com. That's a guy who's electrically sensitive and has measured a lot of cars, and he's also gives his experience of what it's like driving the car. And there are other sites where they've tried a few different cars, but I wish we knew more about to tell you exactly what field level could do what kind of damage. For implants, there's some guidance on that, but for other health issues, at this point, we just don't know enough.
Dr. Olhoeft, do you have closing thoughts here?
I was just thinking of the days where knights in shining armor wore chain mail and rode horses.
Okay.
Not likely a good solution today.
No, not a possible one, probably.
Bicycles.
Bicycles.
They make electric bikes now. You have to avoid those.
Well, thank you both very much, and thank you, Sandi Fields and Interim Occupy, the team, for putting this together. Thank you very much. Sandi, did you want to come in and...
Yeah, I was just disconnected for some reason for a little while, so hopefully we will be able to have a lot of this recorded right away. But even though the recording will be sent to you, the first part of it will be disconnected because I was booted off the system. So also I want to thank you both also for coming on. I'm sorry about the misquote at the beginning. I was wondering if any of you would take any questions at all, because we do have some people with hands up. So would you mind taking a question or two?
We can try one or two.
Okay, great. That would be great. Let's see. We have James Abil. How are you today? Did you have him?
Yes. Everyone has covered all the bases pretty well on what we don't know about automobiles. I wanted to mention a couple of things, though. Put your cell phones in a metal box or cover it 100% with some kind of metal. That way, if you got one you can't take the battery out, that'll prevent it from transmitting and receiving. And my son travels a lot, and he has his cell phone on the dashboard, and the speaker and the microphone is above his head in the ceiling. And as he drives along, he just calls out a number, and the phone dials it, and he hears it, and the antenna's on the roof. So that's a possibility, and probably a little bit less exposure. And I just wanted to thank all the people there, because they have really covered all the bases real well, especially the ones about implants and stuff like that. That's so important. Enough said.
If you want to test your metal box thing, put your cell phone in the box, close the box, and then dial the cell phone. If it rings, it's not working.
Exactly.
Right.
And I can say, this is Katie Singer again, the kind of pot that works, if you go to the thrift shop and buy a $2 stainless steel pot, just make sure that the top of it does seal, and then do the test, call it, and see if it rings.
Good for you. Thanks a lot.
You could also just wrap it in 2 layers of aluminum foil.
Yeah, right.
But it is better to try to turn the phone off and
wrap your passport
in
that too, so people don't pick up the numbers off your passport too, or your travel papers.
The ID on the.
Yeah.
You're talking about the radio frequency ID chip on the
exactly.
passport.
Oh, yeah.
Mm-hmm.
So,
do we have another question?
Okay. How about Judy in Idaho? Did you have a question? How are you today, Judy? Are you still on, Judy? Because she had her hand up for almost an hour. So let's go on to another one. Kathy, how are you today? Kathy in Oregon?
Yes, I just wanted to say that I got an essay sent to me from French today, and I just sent it to you, Sandy. It's called A Law to Regulate Exposure to EMR, and it was posted in Le Monde newspaper in France, 129, which is today. And it says, expected for 2 years, the law governing public exposure to electromagnetic waves generated by wireless was adopted by the deputies in favor of a parliamentary recess of the environmental group. And it was passed by all of the majority. Well, some people had abstained. But it says this is the first law in France to establish a precautionary approach to addressing potential health risks of radio frequency. And it makes it the result of a real obstacle course. So I think the rest of us around the world might want to be watching this thing in France and seeing if we could try to do something like that here. I just thought I'd pass that on to the doctors.
Thank you so much, Kathy. Barbara Payne. Sorry, Barbara. I was trying to get some more questions here because we have a lot more hands up. Barb Payne in Ontario, how are you today? Did you have a question?
Hi, how are you? I apologize if this was already addressed. Tell me, because I was away for a few minutes too. The newer cars, it seems to me there's a plan, or future cars, not very far in the future. I've read Department of Transport, or whatever it's called in the U.S., plans to mandate that all cars have crash prevention radar on all the time.
This was not addressed. Thanks for the question. Dr. Olhoeft, do you want to start with that?
I don't know enough about that yet. I've heard about it, but it depends on whether it's truly a radar or whether it's an ultrasonic sonar kind of device.
What would
the sonar device would be much safer. The radar, if it's a short pulse radar, would be fine. I've been around those. But if it's a continuous CW radar, it would not be fine. And the hazard would be outside the car than to pedestrians more than it would be to people in the car.
I know, that's what I was thinking. Well, obviously people could have their windows open, but yeah, the solution of bicycle is out the window then.
Dr. Bruno?
I hadn't heard about it.
And
There's also a company in California who's making a device. It's an anti-terrorist device to stop cars when they're approaching someplace they shouldn't be. Puts out a very large, high-amplitude electromagnetic microwave pulse to kill the engine's electronics. It basically disturbs all of the computers in the car, and of course that would kill me too if I were in the car. Because
you're wearing, you've got a computer
Because I've got it built into me with the deep brain stimulator, yes. It would hurt somebody with a cardiac pacemaker and other things as well.
Should we take one more call and then close for today?
Sharon, did you have a question? Sharon? You know who Sharon?
I thought of one other thing I wanted to say is that if you have an old car where the spark plugs are the main issue, that getting new spark plug wires could make a difference. And there's a company called Magnacore that makes a special wire that's basically for radio operators who want to use their radio in their car, ham radio. So you might want to check that out.
What's their website?
The company's called Magnacore. I think it's Magnacor.
Okay. So did we have one more question?
Well, I do. I have a silly question. You hear people talking about cars that are going to drive themselves. in the future, and that it's not that far away from this time frame. I mean, can somebody address that issue? Is that something? Have you heard about it? Do you know anything about it? I mean, what is that going to look like? I mean, I don't even know where to go with that. It's science fiction to me.
Google already has cars like that, and it's done with computers. So they're just having powerful computers inside the vehicle, same problem we've been talking about.
So that means it ups the ante, so to speak, whatever that ante is.
The old way of doing it would be the horse that knows how to get back to the barn by itself.
Yeah.
Sorry, I'm not trying to be facetious.
No, but I mean, I agree with you. I don't know where to go with that. But, I mean, I don't know where cars or what cars are going to look like in the future either. I don't think anybody does. But we just addressed basically the basics, I think, the basics of the problem, and you've been very precise.
Let me say that, with, and I'll just full disclosure here, I was in Amish country just a few months ago, and I stay with Amish people, and all I can tell you is that their horses have minds of their own. And so if the horse does not want to go in a certain direction, it won't go. And maybe we're in a similar situation now where some computers have minds of their own. And I don't know if that's what I want to be, in traffic with, is a bunch of computers with minds of their own. It's dangerous enough when there's a horse with a mind of its own, let alone a person. So anyway, that's my 2 cents.
Well, no, that's a very big 2 cents, because I mean, we're talking about singularity, and we don't really want to get into that subject right now. But we're talking about computers really basically superseding what human beings can actually do. And I don't want to get there, but here we are talking about it. But we talked about cars, and I think it's so important to address the issue. And I want to thank all of you so much for being so precise when I'm not. And Katie is. And thank you, Katie, for being the facilitator of this conference. I appreciate that. And all of you for staying tuned to this conference, which I think will be blasted all over the place. So, again, if anybody else has any other closing thoughts, that would be great. Otherwise, we'll end the conference and say thank you all so much for joining us.
There's room for
You're
one
welcome.
Okay. Thank you all. Bye for now.
Bye-bye.
Bye.